Okay, I'm on the second page of notes. And up here in the corner, I want to just talk and think about a few things. If I asked you to give me a math problem of two numbers that added to 10, I know many of you would say 6 plus 4 equals 10. I've had students in the past say 3 plus 7 equals 10. And then I get kids that will say, well, I'll go negative. Negative 5 plus 15 still equals 10. These different math problems, and there's so many more. We could go with fractions and decimals and so forth. They all equal 10. So what I wonder is, does this one equal that one? Does 6 plus 4 equal negative 5 plus 15? Oh, it does. That equals 10. That equals 10. If I wanted to compare these two, does 6 plus 4 equal 3 plus 7? It does. That brings me to my first math problem. When you look at this, line number 1, y equals all of that. Oh, and line number 2, y equals all of that. That just tells me that if they both equal y, in this example over here, 10, 4x minus 1 would have to equal 2x minus 5. All right, I'm going to solve. I bring the 2x's over there, leaving with 2x minus 1 equals negative 5. Be very careful with negative signs. That would equal negative 4. Divide by 2. I have one solution where x is negative 2. Now I need to solve for y. It doesn't matter to me what equation you use. I'm just going to use the top one. So it'd be 4 times negative 2 minus 1. Negative 8 minus 1. Y would equal negative 9. Again, I like to write this with a blank so I don't forget to add the second half of the ordered pair. If I put the blank here, I know I'm solving for the y and not the x. Okay, when I look at question number 2, I notice x equals all of this. And then when I look at this, I notice x equals all of that. So the same sort of idea. I'll take the first equation, which equals x, set it equal to the second equation, which equals x, and simplify. So I'll bring my y's that way. I'll bring my 7 there. And now I have y equals negative 3. So I have one solution. This time I know the y, so I'll put y here and a blank here. Pick either equation. I'm going to pick the bottom. It's just a one step. And I will put that in for y. X would equal 1. If we were graphing, those two lines would cross at the point 1, negative 3. Now we're going to approach a couple problems that are different than the ones we've seen before. Notice in line 1 and in line 2, we do not have y equals a math problem. We do not have x equals a math problem. I need to kind of rearrange that a little. I'm going to choose to rearrange this equation, although you could do this one, and I'm going to set this one equal to x. I can do that in one move. I can subtract. All right, as I was saying, I am going to set this equation equal to x. I can do that simply by just moving the y's over, so I get negative 4y plus 8. Well, now I know what x equals, so I will take that information and substitute it carefully into the second equation. I will have 2 times all of that, because that's what x equals. You need to distribute first. Now combine your like terms, and I ran out of room. Solve your two-step equation. I would subtract 16, divide by negative 13, and get negative 1. So there is one solution where y equals negative 1, so I put the blank where x is. You could substitute that into the two original equations, or you can use that one. So I will have x equals negative 4 times negative 1 plus 8. 4 plus 8, x would equal 12. Those two lines would cross at the point 12, negative 1. I would like you to pause the video and try this problem. Manipulate one of the two equations, I don't care which. We'll compare answers in a moment. Thank you for pausing. I decided to take the first equation, manipulate it around to set it equal to x. I will substitute that into the second equation. I distribute. I have to combine like terms. Oh, so now I am left with the statement 12 equals negative 1. We're going to have to think back to when we were doing this before. Is that a true or false statement? That is definitely false. 12 and negative 1 will never be the same. When you run into a situation like that, that means there will be no solution. Well, what kind of lines create no solution? Hopefully you're thinking about parallel lines. If I rewrote this and set it equal to x, divide by 3, I can see we have almost an identical equation, so they are parallel lines. They will never cross. For the last one, I'm going to, again, just set it equal to x. I will substitute all of that in for x. Distribute. Combine my like terms. Oh, now I am left with the statement 12 equals 12. Back to my question, is that going to be true or false? Well, 12 will always equal 12. Therefore, that is true, meaning we have infinite many solutions. What kind of lines are those? These are actually the same line.